Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So today we are going to discuss about the hydroxides and the carbonates of the group 1A and group 2A elements. So group 1A elements are alkali metals and the group 2A elements are known as alkaline earth metals. So here we are going to discuss about their oxides and about their carbonates. So what does mean by the oxides? Basically, hydroxide ion, it is consisting of one oxygen, one hydrogen atom, and it can be written as OH negative. This is the hydroxyl group, or we can say that the hydroxide ion. When it reacts with the group 1A and group 2A elements, then it changes into the respective hydroxides of the alkali and alkaline earth metals. On the other hand, when we have a look on the carbonates, the substances called carbonates are basically compounds containing a group joined to them which is CO3 negative. So here a group called CO3 minus 2, it is a carbonate. And carbonate shows that it is consisting of one carbon atom that is joined with the three atoms of oxygen. For example, if we have a carbonate and join with the calcium, so the product will be calcium carbonate, which can be read as CaCO3. So this is a simple example of the carbonates. So in this, we will study about the hydroxide and carbonates, all the group members of 1A and group 2A. So the first one we have the hydroxide of alkali and alkaline earth metals. The alkali metal hydroxides are basically crystalline solids. So their physical state is that they are crystalline solids and they are readily soluble in water. So this is their property, they are soluble in water. Just except for one, it is for the alkalis. The one is insoluble in water, which is lithium hydroxide. It is just slightly soluble and mainly they are very strong bases. As they are strong bases, so that's why they are known as alkali metals, except lithium hydroxide, which is having its some properties different from the other members. On the other hand, when we are talking about the solubility of the alkaline earth metals, then its hydroxides are soluble in water and their solubility increases when we move down the group. For example, we have beryllium oxide or beryllium hydroxide. It is quite insoluble. We can say that it is insoluble. But when we move to the next magnesium hydroxide, it is soluble to some extent, or we can say that it is sparingly soluble. Then we have the next, which is barium hydroxide. It is more soluble. So that's why their solubility increases when we move down the group. And their solubility increases. What is the reason behind this? Because they have their higher ionic size. As their ionic size is higher, so that's why they get dissolved in the water. On the other hand, when we are having alkali metals, they are stable to heat except lithium hydroxide, and when their hydroxides are heated, changes into their respective oxides by the production of the water. On the other hand, when we have the magnesium hydroxide, it also produces its respective hydroxide as magnesium oxide and the water molecule. On the other hand, we have a lot of examples of other. We have calcium hydroxide. If we have its saturated solution in water, then it is known as the lime water. So the name here we have lime water. And it is mainly used just to test the carbon dioxide present in the solution. And the next we have magnesium hydroxide. This magnesium hydroxide is mainly known as the milk of magnesia, and it is used as antacid or to remove the acidity of the stomach or any part. So this was a simple overview about the hydroxides of alkali and alkaline earth metals. Next we have the carbonates of alkali and alkaline earth metals. In carbonates there is a group of atoms which is CO3 minus 2. It just get joined with the group 1A and group 2A elements, and it formed their respective carbonates. So the carbonates of alkali metals or the group 1A elements, they are soluble in water. It means they get dissolved in water and they are stable towards heat except the one carbonate which is lithium carbonate. It is not only insoluble but also decomposes upon heating into the lithium oxide. Upon heating, it just changes into the. So the product of decomposition of lithium carbonate will be lithium oxide, and that lithium oxide just decomposes because of the electrostatic attraction. As we are moving down the group, this electrostatic attraction just finished. In turn, we have another carbonate which is potassium carbonate. So it is difficult to decompose it because the gain in electrostatic attraction is relatively much less as compared to for the lithium because their atomic, or we can say that their ionic size. On the other hand, as we have the other carbonates of the alkalis, which is the sodium carbonate. Its formula is Na2CO3. It may have the water molecules that is attached to it as the water of hydration. It can lose the water slowly, and upon the loss of the water, it will be converted into the white powder, and after that its formula will be Na2CO3, though smaller water molecules, and upon hydrolysis with water, as it is basic in nature, so it will be changes into the carbonate ion. For example, its dissociation, we have sodium carbonate. Upon hydrolysis it produces a base which is sodium hydroxide and carbonic acid, that is H2CO3. Unlike the other alkali metals, the carbonates and the alkaline earth metals, their carbonates are really slightly soluble in water, because when we move from left to right the ionization energies are increases, but when we move down the group their solubility decreases in water. For example, we have beryllium, magnesium, we have calcium, and we have strontium. As their carbonates are insoluble in water because their solubility decreases moving down the group in the periodic table. So they also decompose upon heating. So this is the thing which is common in both the carbonates of alkali and alkaline earth metals. They decompose upon heating. For example, have we have calcium carbonate. When we started to heat that calcium carbonate, it decomposes into the calcium oxide and producing the carbon dioxide. So this decomposition is just because their lattice energy is low. So the decomposition can also be related to the simple size of the metal ion. When the size is smaller, then there will be the more lattice energy and the resulting oxide will be having higher the stability of the product that is composed upon heating. So this was a simple overview about today's lecture. I hope you guys understand, and if you have any queries you may ask me about that. And the next topic that we will discuss, it is the nitrates and the sulfides of group 1 and group 2A elements in the periodic table. For that time, you guys have a good day and keep learning.